Okay, welcome to this afternoon's, well, actually today's only on-site session. Um, I'd like to talk about error messages in Snap and specifically what I changed about them last night after being in Eddie's session and after Brett's call to arms, like what can we change about error messages here and now? I didn't have to sit down because I was already sitting, so I could just commit some things and change them and deploy them. And what I really want to talk about is this programming is hard. And it really is hard. There is no question about it. And it even is hard where we don't expect it to be hard. Like we've seen many cases where not just novices, but where we all struggle with enigmatic error messages. Many of them have to do with syntax, with forgetting something or the other, with getting an error message which is sometimes angry, sometimes discouraging. And I really appreciate all the efforts to make that easier to start programming. I really enjoyed Felina's talk about Hedy, and so I'd just like to start with Hedy. Just before, just before I got here, I already mentioned this. Congratulations, Felina Hedy was featured in the German newspaper Heise as a graduate programming language that does not have any syntax in level 1, but it only adds syntax later. And we've seen a great demonstration about it. So here's Hedy level 1. It says print hello, and I can run the code print hello, and it's amazing. It makes hello. And so I can type stuff in here. And now watch what happens while I type. So I'm saying P, and now kind of print gets white. I say please. It's still white. I enter a space. Oh, it's okay. It's getting print again. So I'm saying run the code. And it says we can't run your program because it looks like I forgot to use a command on line 1. But I did not forget a command on line 1. It's there. Hedy even noticed it as print. So Felina is going to fix this tonight, just as I was fixing Snap last night. See, this goes to show, right? Programming is hard. Like even when we have kind of the least imaginable programming language of it all, like we can't catch everything that is imaginable. So we've talked a lot about syntax, right? And sometimes I'm not sure whether syntax is just a symptom or the cause of the problem. So here's a sentence. It doesn't have any interpunctuation. But, there are people in this room who know all about this, who studied this. When I go back to my kind of school time, we had to color these things, kind of syntax highlighted. Yeah, there's parts of speech in there, right? There's even you can kind of analyze it, subject, predicate, object. The object is kind of the predicate and the full object. So maybe even just this thing really is dual, kind of nested thing that's behind. So there's even syntax there when we don't think about syntax, but syntax is what kind of signals an error. And the question sometimes is syntax actually the problem? Like, does a programmer that starts a program, do they really not know the syntax of a conditional, or did they maybe just forget one of these funky letters? If you ever tried typing a square bracket on a German Mac keyboard, I'd like to talk to you about accessibility again. So often, syntax is just where the stuff shows. What really is a problem is stupid markup. You're just forgetting to hit a key. But then the computer kind of makes something more about it and tells you, oh, you've got some misconception about syntax. And they go, oh, wow, that's grammar. That's really hard. But in fact, the error is on a different level. And so what about blocks? Sorry, Felina, I didn't really want to talk about Hedy, but couldn't resist. So this is where blocks kind of seem to help. Because, okay, wait, where have the kind of in the looks category, there's something that says hello for 2 seconds, and if I click on it, it says hello for 2 seconds, and this is really kind of like a widget.
It's confusing because it doesn't say hello for 2 seconds. It says hello for 2 seconds.
Yeah, but you kind of see, that there's lots of syntax in here. There's colors, there's all kinds of, it's a widget, it's like a window, right? And I can't rearrange the stuff that's inside the block. So that seems to sort of make it a little better, and there's only certain ways in which you can arrange these blocks, so you can't put another statement inside the hello, and that appears to take care of most syntactic issues, and it's of course great, which is why I'm showing it to you, and there are other blocks that only belong in there, but it comes at a price. Everything comes at a price, and the price really of blocks programming, excuse me, yes?
He was asking if there's a please block in Snap.
Right. So one price about this, if you look at this, is cognitive overload. Instead of just seeing a text, what you see here is this window full of syntax. Basically, all you see is syntax, and this kind of makes it possible for you to deal with it without having to think about it. But there's more prices. Like there's a whole cognitive load of where do you find the blocks? Like instead of remembering them, you quickly get overwhelmed by kind of deeply nested things. And then there's the question like, does Snap have syntax errors? And at first sight I'd say no, but one thing about Snap and about programming that's really exciting is abstraction. I mean, that's really what we like to do. So in Snap, we have these command blocks that look like puzzle pieces. We have the round blocks that are reporters, kind of functions that return something. And in the operators category, you also have these gray rings, and the gray rings is really what makes Snap special. It's an abstraction. So I drag out a gray ring, I put the say hello block into the gray ring, and I click on it, and it does not get evaluated. It gets ringified, kind of rayified. So I now can make a variable. Variables have to be named foo, and I can assign that variable to the ring that has say inside, and I can see that there is say. I can get the variable out. I can click on it. It has the say foo block in it. And now I've abstracted the block away. I've given it a name. It is no longer a puzzle piece. It is just a variable, and it has become a procedure. And I can call that procedure. In this case, it's a statement. It's a command block, so I'm going to run it. So I'm running foo, and it's again saying hello for 2 seconds. So what if I want to say something else than hello? So in Snap, I can just empty these slots. So now I'm saying for seconds. I can reassign this. So now I have the say for seconds procedure inside foo, and I can run that, and I can pass in some inputs. So I can say hello world for 3. I'm getting an error message. I'm getting an actual syntax error. Because, lo and behold, I've abstracted away the syntax. I've abstracted away the block into a function, into a procedure. So, yes, I'm getting an error message, and I'm getting a veritable syntax error message. And that's kind of obvious, but it's also kind of discouraging, because I'm thinking that I'm at this other level of abstraction where I'm thinking about functions, about maybe even functions as data, and now I'm sort of getting caught up with a syntax error. And oh, by the way, as we're talking about these error messages, yes, please.
So, can we talk about whether or not this is a syntax error? Because it's also somehow a semantic error, right? There is something that is a function that requests a certain type. It's not necessarily about the grammatical, textual shape, if you could talk about that in Snap. So
I'm not getting into esoteric arguments about what semantics are. I'm just a lawyer. I'm sorry about this, but I'd say it relates to how things about the parts of something and how they belong together, and I'd say it's syntax error, but if you believe it's an error, and it's an error that comes out of giving the wrong amount of inputs or in the wrong order, it's an error. It has to do with the structure. You can't do it. You can only do it once you leave the abstraction level that Snap provides out of the box and go to another abstraction level. And that's kind of the mean thing about it. I just wanted to let you know that, here's the stuff that I changed last night about it. It said error. And I made a commit that now it says, so it's, right? It's kind of, and we were kind of discussing in the team whether we could leave out the but there are actually some errors that give us more information about what the error is, and I didn't want to just take these out. So I'm saying, and it kind of makes it more like it's not the user's fault, but maybe Snap's fault for being confused about what's going on. And by the way, we can localize this, so we can look at this in, for example, Portuguese. Does this work? Yeah. So if I execute this, error message in Portuguese. We do it in Chinese. I don't know. Does it also work? I don't know what that means. I hope it means the same thing. Go back to English. So, where's English? Oh, here it is. Okay, good. So, good. I can read this again. So the main thing about this is, that errors can kind of teleport you out of one level of abstraction into something that you don't want to deal with. Kind of your mind is thinking about something else, but you're pulled into this other world that's kind of like a culture shock, like a domain shock, and that's what I find particularly mean about exceptions and error messages in general. And that's even worse if, like in Snap, the error is only caught at runtime. Snap is not a compiled programming language, but an interpreted one. And the reason is we want to make it tinkerable, we want to make it discoverable, kind of you can experiment with it. But the downside is, of all this liveness, the downside is that the error, the exception, only happens like when you're in the middle of running a program and not ahead. And so kind of, I want to quickly venture into territory that's not about semantics and syntax, where I'm feeling much more secure, which is law. Just going to talk about the law. What do we do with these things? So in the law, we kind of have guidelines how to understand, kind of rules for understanding how to make sense of what people say when it's about contracts. And this is the German Civil Code, and in section 133, it says, unsurprisingly, you're supposed to explore the real will, kind of what the person actually means, and not stick to the literal sense of what they might mean. But that's only for unilateral expressions. For mutually binding expressions, section 157 says, you're supposed to interpret it how an objective third person who is kind of in the same society as you would objectively be able to understand it. And one of the examples is, like, there's a guy, let's call him Klaus, and he has a friend, Hans, and he says, okay, after I'm dead, Hans gets my library. And after he's dead, they find out that he only has a bookcase with a few cheap books. But then kind of people say, but oh wait, whenever he was meeting with Hans, they were disappearing in his wine cellar. And he used to call that his library. They were going into his wine cellar to have wine, and it turns out the wine cellar is really, really expensive. And so the question is, does Hans get the wine cellar or the cheap books? And in this case, since it's a unilateral expression of intent, the real will has to be taken, and not what anybody, any third party could understand. And so another, like, if we're thinking about how discouraging programming language errors can be, I invite you to look at the law and kind of find out what reading that language does to you, whether kind of what sentiments and emotions those evoke. Like, here's another thing, like, okay, if part of a contract is void, like it's broken, the whole thing goes downhill, like it's all null, except And always when there's a double negative in German law, that's really an indicator of a burden of proof rule, except if they didn't mean that. And there's, again, an exception if it's about a last will and testament, because then the guy who's like that says the whole thing will have to uphold. Only the part that is void should be stopped. And so this is something that might be a really bad idea, but this is something where I'm feeling a little bit more at home. Kind of when we think about who will be experiencing, who will be the addressee of a programming language in Snap, since it's an interpreted programming language, it could be the programmer, it could be the learner. We don't know. It could just be a kid who's sharing something they've written with a friend. And now the friend is getting that error message because it's happening at runtime, so what are we going to do about it? And then they have a problem. So here's Jens's wacky idea, which I'm calling the deceased programmer proposition. So in Snap, I'd like to, evaluate an interpreted program as if it were the kid's last will and testament. I want to explore the real will, kind of what they actually meant, not what, their teachers might expect them to mean. And I want to be really benign and not have too many exceptions. Might be a wacky idea. Let me actually kind of dive a little deeper on this. And this is something that we're experiencing often, that when we get an error message or when we get a bug or something, when kids try to do something and we say, no, you can't do this, because, and then we think about, wait a minute, why because? Maybe it's actually a great feature. For example, let's say we have the say block, and we say something for 2 seconds. Or let's just say something for anything, like we say. Let me hide that. We say hello. We can also say the result of 3 plus 4, yeah, that's okay. But what if we say the numbers from 1 to 10? So that's a list. So what should we do? Should we say, you can't say a list? And then Snap, we just decided to, we'll just, open up a speech balloon, and it'll even be editable, so we can say, okay, this is 42, and this is a Dachstuhl. So it's sort of a way to, if we can be, and if it's not too much stretching it, we can be polymorphic about things and kind of maybe override and mix domains. So another thing, like as we were giving a course to teachers in Erlangen 2 years ago, what they like to do in classes, they like to do the Caesar cipher, because the Caesar cipher is really great, not because it's a great cipher, but because it has all these technicalities that let them introduce what Germans think is an important programming concept. So, like we have the split hello world, we can split it by words, or we can split it by letters. Now we want to convert the letter to a number, so we could write. So how do we convert a letter to a number? We can get the Unicode of A, that's 79. So how do we get the Unicode of all these letters? And of course, what we usually teach them is, or we don't teach them, they say they need a for loop, they need, I guess, a variable, which says the letters, then they're going to set the letters. And you get the idea. I don't have to do this, right? And then they kind of say till the length of, and we say, isn't there a better way? Isn't there, maybe not necessarily a better way, but a different way? And what we want them to come up with is a map. So we say, we can throw away all of this. We just can say map Unicode of A into this, and let me get the list. And these teachers didn't know map, and they were guessing, like, why can't we just do this? And we said, no, you can't do, because it's a different domain, because, Unicode takes a number, and you're getting a list. And we said, wait a minute. That's actually maybe a neat idea. There was a language like that, APL, right? That kind of had list comprehension and J. And actually, if you think about it, our goal here is to reduce the cognitive burden of the Caesar cipher. We actually want to talk about monoalphabetic substitution and about how you can make your, like, we don't want to teach about how to access an array by indices. So maybe for this particular case, it might actually be great to make the domain possible so we can do this. And then we could just say, okay, what if we have a list of numbers and we want to shift that by 2 so we could have an arithmetic operator? Are we stretching it, saying, oh, what about this? And what if then we would just want to turn it back, say, now we've got the Unicode of all of this. Isn't that kind of neat? Because what's left really is what we want to teach. What's left really is the idea of a Caesar cipher without having to think about, oh, do indices start with 0 or start with 1, or kind of having all these discussions. And we can sort of debunk the thing that all the technicalities they need of what programming is and really cut down to what it is about. Yes, please, Janet.
We have a small question from Jan. He asked why the title of the window is still in Portuguese that says Sim Titulo.
That's the title of the program.
That's probably a bug because I changed to Portuguese and then that was preserved because before I changed to Portuguese, it was not saved yet.
Jens, could you repeat the question, please?
The question is why it says sem titulo and not.
Oh, got it. Thank you. Thank you.
So once we have this, it's kind of an interesting thing. So now we've kind of overloaded arithmetic operators and functions with things, and that opens up a whole realm of things that we can do without getting an error message. So so, for example, I'm going to take this picture of me. Okay, so I got 2 pictures of me. And so now we can go, for example, we could go to looks and we can say, okay, here's my costume. I got like the camera. I can get the pixels of this costume. And it's a table. A table in Snap is basically a list of lists. It's got 172,800 rows. It's basically a list. So as soon as we have a 2-dimensional list, we represent it as a table. So yeah, I've also got this other picture that I made. That's camera 2, I think. That's also a table. Hey, I can't just use plus, right, on numbers and lists and multidimensional data, so I can just do this. And now I get a table that combines all of this. So now kind of the values don't really make sense at like 510. Maybe I should average them. Wouldn't that be kind of neat? And so I can click on this. I'm doing this with lots of data. And I want to see this. So what if I switch to this costume now? And see what this does. And, oh, look at that. I sort of get this overexposed image where I can just add the data, not the 2 images, the pixel data of the 2 images. And it's kind of interesting, like rather than giving an error message, this might be something that a kid might actually mean. They might also mean something different, but I just kind of like it. So for example, we could do something like, let's make a variable with the pixels, and instead of doing this, let's assign the pixels to be not the pixels of the camera, but the pixels of, look at that, there's a video snap on the stage. And then I'm just going to add the pixels to, there's another thing to the reverse of the pixels. What if I do this all the time, like forever? I kind of get this kaleidoscope that is interactive, and I can transform video, kind of do these interesting effects, all with kind of matrix operations on the pixels of live video. So this is kind of an idea to extend the domain gently of some operations, so we don't have to throw a type error. So we can explore a little further what kids might actually want. Another idea that we got from kids, at one time I had a bug in Snap. And so here are these hat blocks that are really events, and one of them is, it says, when I am, like when I am clicked, let's again say hello. And now I, not me Jens, but the sprite, when I click the sprite, it says hello. And I made a bug in Snap, so people were doing this when I am touching mouse pointer. Like now you can't drop it into the hat block, but one night there was this problem, and next morning I got all these error messages from teachers and kids saying, oh, Snap is not working, this doesn't work. And I was, oh, I'm sorry, this is my problem, you're not supposed to be able to drop this in there. Wait a minute, why not? Maybe this is actually a cool idea. And this led us to add the generic when hat block that is something of a thing that, you know, as a programmer I shy away from, because it's kind of like a rule. Now, whenever this happens, I want to be able to do something that is almost like a constraint, like a condition. And so basically what I'm saying is, you know, errors can indicate missing language features, and we're not doing this with everything, but in the spirit of treating a program as the programmer's last will and testament, we're trying with some of these things to do just that. So there are other error messages in Snap. I'm just going to show you a couple of ones. This is a thing in progress. Sometimes we'll decide that we need to catch an error, that we might want to give a better indication of what's wrong. Sometimes we decide to overload it with something else, with a different domain. So there are some, like here's a variable and foo doesn't exist in this context. It's actually kind of hard to produce this error message, so I first have to make a variable, take it out, then delete it again, but you know, such things happen. There are type errors, like length of, like, you know, expecting a list, but getting a nothing. Okay, linguists will disapprove. There's something wrong with the grammar. Or there's a definition of the timer, expecting command, report, or predicate. And where it gets a little more tricky is if it's inside a custom block. Like, if you click on this, this is something that Michael Ball kind of had the idea to give a little bit more of an indication than just a text. Kind of what's the problem, what could be more of an indicator. It says, okay, it's inside a custom block. It's inside this custom block. There is an error because we're not seeing the inside of the custom block. That's kind of the idea of abstraction. It says, okay, there is an error, and oh, that's another thing I changed last night. It says the error occurred at, I changed it to the question came up at. So it's something that you might provide some more information. And then how do you find this? So another thing in Snap that I'd like to talk about some other time is how do we trace these things? So in Snap we can do visible stepping. There's a slider that reduces the execution speed, so we can run it slowly. We can open this up, and once we've got something open, we can actually kind of see where things happen, and then we're trying to show where it is in the code that you're seeing. But of course, sometimes you're not seeing the code. Sometimes it's the kid's friend seeing the code because they shared the project with somebody else. So what do we do then? And so we're not showing all the contextual information. We're just kind of showing there is an error, but yeah, and then, you know, they might try to trace it. But we're assuming that they just might be consuming the game or something. So yeah, we have type errors, we have other kind of things, and they're really kind of finite. So if we don't have any pen vectors, we say so. There's gentle things like when we have this when hat block, which is kind of constantly evaluating, and you can put something in there that takes too long. We try to say, oh, a predicate takes too long for a custom block to, so you might want to look at that and find out what's wrong with that. Or we have a classic, a buggy reporter. Oh wait, I need to make this faster again. So a buggy reporter, which would say the reporter did not report. That might not be the most clever way to phrase it. If you open it, you'll find, there's a report statement, report block, that's our return statement that's not attached to it. So it was expecting something. So there are error messages in Snap. We try to localize them where we can. We try to give some indication of where it occurs. When you're in edit view, then we're assuming you're the programmer, you want some more information. When you're not in that view, we try to kind of not give too much information. And we also, kind of in the sense of this legalese I showed you, like when an error happens, we don't stop everything, but only, it's a concurrent programming language, we only stop the thread, the process where it occurs. So you can still, the thing is still live, you can then, and this is something I'd like to talk about maybe sometime else, you can then in the IDE dig into and expect the variables and kind of trace it and see what happens. And that's kind of the thing that I said about Smalltalk, which has kind of converted me to love programming. This is something that we try to aspire to. We haven't reached yet by far, to make a welcoming environment that lets us find out what happens and lets us trace things. Let's kind of do things like visible stepping. But there are also other things, and I can't go into them. I'm just saying that these might be interesting things to talk about since we haven't touched any of them in this seminar. We're still stuck at the stage of syntax errors. Like, Snap is a parallel programming language, and there's all kinds of interesting things that can go wrong with parallelism, like race conditions. So I remember a couple of years ago, I got this email from Moti Benari, who was using Snap to teach race conditions. He said, yes, I'm having difficulties producing the errors I want to produce because you seem to have some hidden protected sections in there. I said, yes, we do. Well, in fact, let me tell you all about it. He said, well, can you maybe not do this? So I said, well, let's maybe discuss this sometime. So these are interesting things that also go to the design of a programming language for learners, maybe as opposed to professionals. And also, there's tons of compromises in there. Like, none of the principles that I'm saying, that I'm telling you, are really hard. This is kind of more of like something, oh, maybe we could fix this, maybe we can address this. There are terrible things, and I should show you some terrible things, so not only Hedy comes along as, something that still has bugs in there. Snap is full of bugs. For example, sometimes the underlying JavaScript seeps through. For example, in the map block, which I'm so terribly proud of that I can't believe I forgot to put this in. I didn't put in a type assertion for whether it's a function. So here, I'm not getting I'm getting type error, because JavaScript tells me type error, and then it says, cannot read properties of undefined reading length, and whoever knows what that is, and we can't translate that because I can only translate what I'm looking for, but whenever I'm specifically looking for something, that slows down Snap, especially if many things are running in parallel. And it's better to be correct than to be fast, except when there's teenagers involved who then complain that Snap lags, let's do it with, Scratch. So there are all these compromises to weigh through, which is why we still can have a few of these terrible error messages. And in this case, I actually want to know the errors so I can trace it and fix it. In wrapping up, programming is hard, no matter what we do. Even if we make it really easy, it is hard, and we shouldn't deceive ourselves that we can make it easy. In fact, maybe the whole purpose is not to make it easy, but to make it more welcoming. To encourage learners to, yes, do it, it's hard. It's like, that mountain. You're going to be really glad once you've reached the top. It's hard. Don't tell me I didn't tell you. And blocks can help get over that initial hang-up where you sort of have this feeling of rejection that the computer or the language hates you because you're doing something invalid or illegal, or you're just not getting it. This must be easy because you're not even getting, hello world done. So how are you going to do everything that comes later? So especially if you're not doing this full time, if you're not doing this for a major, especially if you're doing this maybe just once or twice a week in class, especially if you really just like to play soccer or play the guitar and you just need to do this computing thing. This might be something to get you over the initial kind of rejection, so you can actually progress towards having to struggle with the lowly syntax errors, from having to struggle with the lowly syntax errors towards dealing with more interesting and engaging, sophisticated semantic ones. That's the last time I'm going to use semantic. Thank you.
Questions?
Feline, go ahead.
Yeah, so I'm super impressed with that video overlay. I'm still processing how cool that is. I'm wondering though, how to communicate to students this is something you can do. So I love this idea where you're saying an error message is an opportunity to add power to the language. But traditionally here you would say something like you cannot apply plus to video streams, which is also a teaching moment, and the student understands hopefully that these are not two things you can add. Now you're just doing it, which is fantastic. But then what is the expectation of how to figure this out? Is this a teacher should explain this? Is there documentation somewhere where you can see which types allow certain operations?
So Feline, I don't know, for the remote people, Feline interjects that it's unclear kind of with this, what the domain of the block is. If it, do kids have to kind of explore it themselves? Do they need a teacher? Is there documentation? Is it a good idea? I was originally gonna name my slide like some probably bad ideas, but then I didn't want to come across as, not really meaning it. But yes, this is a discussion we're having, and it's a compromise. I was talking about that cognitive overload of having too many blocks, of having to find them. So one of the maybe bad ideas is, well, if you just have few of them, but they are kind of more like Swiss Army knives, kind of, you kind of MacGyverize the UI and you can do many things with it. So do we need a teacher? Yes, of course we need a teacher. Yes, of course we need a curriculum. And of course, kids can do some exploration on their own, but you're not going to teach kids higher order functions without a teacher or without a curriculum, and this is what we're after. And you're probably, maybe accidentally going to step into recursion, but you're not going to learn about recursion without a teacher, especially not about, branching recursion, maybe about jail recursion. So yes, there is, I might as well say this in public. I'm working together with constructionists, but I'm sort of a half disillusioned constructionist. I think that there should be really well-constructed curriculum and really engaged and able teachers who have a plan what to teach you, and then the language should support it and should make it welcoming and should try to reduce all the crap that you have to learn in order to get a big idea across.
But even more so, maybe we can also have, so you saw this amazing thing in Hedy, like we also have positive messages, right? We give positive feedback. So maybe in this situation, you could also, instead of giving the error message, you cannot add video to video with a plus, you could also give a positive message where you say, congratulations! This is also a thing you can do to explain, hey, I like this, error messages are opportunities to expand the language, but then you sort of lose the explanatory power, but not necessarily, because you could give a message like, yay, confetti, you found the
Right,
picture, or something like that.
You're right, you can gamify it. You can get badges for kind of solving a problem or for doing something right. I'm personally not so much interested in this. To me, Snap isn't supposed to be like a game you play, but something that you maybe come up with your own game. It's not like, so we're not having these levels. And I'm not saying, you shouldn't have them, Feline. I'm just saying, Snap, why I make Snap is to support the beauty and joy of computing curriculum, not to give out badges.
We don't call error messages gamification, but they are negative messages, or saying you cannot do something. So I'm not sure if we say, hey, you did something that is okay, I'm not sure if that's immediately already gamification, because it's sort of the mirror of an error message.
Yeah, it's an interesting idea to me. I don't know. It's usually when the thing does what I expect it to. That's like my yay moment. I want this to happen. Look at that. I can make it happen. I think that's really motivating. I really think we're pretty good in demotivating learners and in demotivating kids. So it's about, I really think if we work on reducing the demotivation, that's kind of really going a huge step, because they already are programming, so they must be motivated already. So let's not, turn them away. Tobias, please.
I just want to say I absolutely love the sentence you had up there. Sometimes an error is that means that we have to implement a new feature in the language. And I've seen similar things that my students did in Python. And to be honest, it was usually the girls who were not really into computer programming who came up with these algorithmic, absolutely valid ideas and a very straightforward way how they put that into the code. But they didn't use as many variables as they were supposed to in order to get valid Python code or whatever, similar to what we've shown here. So I think there's a huge pool of resource that we could tap into by looking at what kind of ideas do the students have that we could bring into the language in order to kind of make them more accessible. So that's not something that's just in Snap. I've seen that in Python. I think it's a great idea. I love it.
Thank you very much. In fact, we did look at APL, J, and at NumPy to find inspiration for this. I'm a little nervous because I don't want to take away any time from Michael. And I think we're about halfway through the time.
Yeah, maybe one question.
Okay, maybe one more question.
Okay, so we reserve that then for the wine cellars, Melanie. And then thanks again.